I would like to point out some practicalities behind hypothesis testing. So when we say that we reject the null hypothesis, that means that we automatically accept the alternative hypothesis and say that the alternative hypothesis might be true. When we reject the null hypothesis, we also say that our finding is statistically significant. And when we do not reject the null hypothesis, we say that our finding is not statistically significant. So when we cannot reject the null hypothesis, that means that we have to accept it. And all we are saying is that on the basis of the sample evidence, we have no reason to reject it. We are not saying that the null hypothesis is true. So this is very important. So we just do not reject it, but it doesn't mean that the null hypothesis is true. So once again, when we reject the null hypothesis, that means that we accept the alternative hypothesis. When we reject the null hypothesis, we say that our finding is statistically significant. When we do not reject the null hypothesis, we say that our finding is not statistically significant. And not rejecting the null hypothesis means that there is just not enough evidence to reject it. There is a wonderful 2T rule of thumb, which I would like you to remember. So if the number of degrees of freedom is 20 or more, and if the level of significance chosen by you is 5%, then the null hypothesis that our estimated coefficient is equal to 0 can be rejected if the t-value computed using equation number 3, which I will show to you now, right? The t-test equation. So if this estimated t-value, t-statistic is higher than 2, in absolute value, then we reject the null hypothesis. So once again, if the estimated t-statistic is higher than 2 in absolute value, then we reject the null hypothesis that our estimated coefficient is equal to 2. So this is the so-called 2T rule of thumb. And to be able to use this rule, the number of degrees of freedom should be 20 or more, and the level of significance should be 5%. And I've been talking a lot about the level of significance, and so therefore decided that I need to be a bit more specific about it. In statistics and econometrics, there are 3 commonly accepted levels of significance: 1%, 5%, and 10%. The most popular one is actually 5%, because 1% is too strict and 10% is not strict enough, whereas 5% is right in the middle, so it's more or less okay. So the lower the significance level you choose, the higher chance of accepting the null hypothesis, right? Not being able to reject it. Or on the other hand, the higher the level of significance you choose, the higher the chance of rejecting the null hypothesis. So it's actually up to you to decide whether you want to be very strict, then yes, you should choose 1% significance level, or if you don't want to be too strict, then you can choose 10%. However, to be on the safe side, I recommend you to use a 5% significance level. And there is another interesting aspect of hypothesis testing, and it is related to the p-value analysis. So instead of calculating the t-statistic and going to the table and looking for the critical t-statistic, what we can do, we can just actually obtain the p-value of the estimate and compare it with the significance levels, right? The one that I mentioned on this slide. So, and if the estimated p-value is higher than the significance level, then we accept the null hypothesis. So if, let's say, we got the probability of 15%, it is higher than any of these 3 significance levels, then unfortunately we cannot reject the null hypothesis and we have to accept it. However, if the estimated p-value is lower than the significance level, then we reject the null hypothesis. So let's say we get the p-value of 0, it is definitely lower than 1%, than 5%, or than 10%, then we can say that we are able to reject the null hypothesis. Luckily, we don't need to calculate those p-values ourselves. The econometric software will do this for us, and actually all of them report both t-statistics and p-values, so it's actually up to you which statistic you want to choose. But personally, I prefer and I recommend you to use the p-value because this is the easiest, the quickest way to do that. If you decide to use the t-statistic, then you will also need to report the critical t-statistics, the one that you get from the table of t-distribution, and I think it takes a bit too much of your time.